The next era for robotic systems is going to be, robots. And these robots are going to come in all kinds of different sizes. And I invited some friends. Did they come? Hey, guys. Hurry up. I got a lot of stuff to cover. Come on, hurry. Did you tell R2-D2 you're going to be here?
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Hello, Las Vegas! Happy New Year! Welcome to CES. To kick off this new year. Well, every 10 to 15 years, the computer industry resets. A new platform shift happens. From mainframe to PC, PC to internet, internet to cloud, cloud to mobile. Each time, the world of applications target a new platform. That's why it's called a platform shift. You write new applications for a new computer. Except this time, there are two simultaneous platform shifts, in fact, happening at the same time. While we now move to AI, applications are now going to be built on top of AI. At first, people thought AIs are applications, and in fact, AIs are applications, but you're going to build applications on top of AIs. But in addition to that, how you run the software, how you develop the software fundamentally changed. The entire five-layer stack of the computer industry is being reinvented. You no longer program the software, you train the software. You don't run it on CPUs, you run it on GPUs. And whereas applications were pre-recorded, pre-compiled, and run on your device, now applications understand the context and generate every single pixel, every single token, completely from scratch every single time. Computing has been fundamentally reshaped as a result of accelerated computing, as a result of artificial intelligence. Every single layer of that five-layer cake is now being reinvented. We have billions of dollars of supercomputers in operation so that we could develop our open models. I am so pleased with the work that we're doing. It is starting to attract attention all over the world and all over the industries because we are doing frontier AI model work in so many different domains. The work that we did in proteins, in digital biology, La Proteina, to be able to synthesize and generate proteins, OpenFold 3 to understand the structure of proteins, Evo 2, how to understand and generate multiple proteins, otherwise the beginnings of cellular representation. Earth 2, AI that understands the laws of physics. The work that we did with ForecastNet, the work that we did with CorrDiff, really revolutionized the way that people are doing weather prediction. Nemotron, we're now doing groundbreaking work there. The first hybrid transformer SSM model that's incredibly fast and therefore can think for a very long time or can think very quickly for not a very long time and produce very, very smart, intelligent answers. Nemotron 3 is groundbreaking work, and you can expect us to deliver other versions of Nemotron 3 in the near future. Cosmos, a frontier, open, world foundation model, one that understands how the world works. Groot, a humanoid robotic system, articulation, mobility, locomotion, these models, these technologies are now being integrated, and in each one of these cases, open to the world. Frontier humanoid robotics models open to the world. And then today, we're going to talk a little bit about Alpamayo, the work that we've been doing in self-driving cars. Not only do we open source the models, we also open source the data that we use to train those models. Because in that way, only in that way, can you truly trust how the models came to be. We open source all the models. We help you make derivatives from them. We have a whole suite of libraries We call the NEMO libraries, physics NEMO libraries, and the Clara NEMO libraries, each bio-NEMO libraries. Each one of these libraries are lifecycle management systems of AIs, so that you could process the data, you could generate data, you could train the model, you could create the model, evaluate the model, guardrail the model. And so not only are these models frontier capable, not only are they open, they're also top the leaderboards. This is an area where we're very proud. They top leaderboards in intelligence. We have important models that understand multimodality documents, otherwise known as PDFs. The most valuable content in the world are captured in PDFs. But it takes artificial intelligence to find out what's inside, interpret what's inside, and help you read it. And so our PDF retrievers, our PDF parsers are world-class. Our speech recognition models, absolutely world-class. Our retrieval models, basically search, semantic search, AI search, the database engine of the modern AI era, world-class. So we're on top of leaderboards constantly. This is an area we're very proud of. And all of that is in service of your ability to build AI agents. This is really a groundbreaking area of development. You know, at first when ChatGPT came out, people said, you know, gosh, it produced really interesting results, but it hallucinated greatly. And the reason why it hallucinated, of course, it could memorize everything in the past, but it can't memorize everything in the future, in the current. And so it needs to be grounded in research. It has to do fundamental research before it answers a question. The ability to reason about work is now being integrated, and everything that I just described, we have the benefit of working with some of the world's leading enterprise platform companies. Palantir, for example, their entire AI and data processing platform is being integrated and accelerated by NVIDIA today. ServiceNow, the world's leading customer service and employee service platform. Snowflake, the world's top data platform in the cloud. Incredible work that is being done there. CodeRabbit, we're using CodeRabbit all over NVIDIA. CrowdStrike, creating AIs to detect, to find AI threats. NetApp, their data platform now has NVIDIA's semantic AI on top of it and agentic systems on top of it for them to do customer service. But the important thing is this: doing it inside a computer. And we've made enormous progress. Today, we're announcing Alpamayo, the world's first thinking, reasoning, autonomous vehicle AI. Alpamayo is trained end to end, literally from camera in to actuation out. The camera in, lots and lots of miles that are driven by itself, where we human drive it, using human demonstration, and we have lots and lots of miles that are generated by Cosmos. In addition to that, hundreds of thousands of examples are labeled very, very carefully so that we could teach the car how to drive. Alpamayo does something that's really special. Not only does it take sensor input and activates steering wheel, brakes, and acceleration, it also reasons about what action it is about to take. It tells you what action it's going to take, the reasons by which it came about that action, and then, of course, the trajectory. All of these are coupled directly and trained very specifically by a large combination of human-trained and as well as Cosmos-generated data. The result of it is just really incredible. Not only does your car drive as you would expect it to drive, and it drives so naturally because it learned directly from human demonstrators, but in every single scenario, when it comes up to the scenario, it reasons about, it tells you what it's going to do, and it reasons about what's about to do. Now, the reason why this is so important is because of the long tail of driving. It's impossible for us to simply collect every single possible scenario for everything that could ever happen in every single country, in every single circumstance that's possibly ever going to happen for all the population. However, it is very likely that every scenario, if decomposed into a whole bunch of other smaller scenarios, are quite normal for you to understand. And so these long tails will be decomposed into quite normal circumstances that the car knows how to deal with. It just needs to reason about it. Will be autonomous. And we've been working towards that future. This entire stack is vertically integrated, of course, in the case of Mercedes-Benz. We built the entire stack together. We're going to deploy the car. We're going to operate the stack. We're going to maintain the stack for as long as we shall live. However, like everything else we do as a company, we build the entire stack, but the entire stack is open for the ecosystem. And the ecosystem working with us to build L4 and robotaxis is expanding, and it's going everywhere. I fully expect this to be, well, this is already a giant business for us. It's a giant business for us because they use it for training data, processing data, and training their models. They use it for synthetic data generation in some cases. In some companies, they pretty much just build the computers, the chips that are inside the car. The next era for robotic systems is going to be, robots. And these robots are going to come in all kinds of different sizes. And I invited some friends. Did they come? Hey guys, hurry up. I got a lot of stuff to cover. Come on, hurry. Did you tell R2-D2 you're going to be here? Did you? And C-3PO? Okay, all right, come here. Now one of the things that's really, you have Jetsons. They have little Jetson computers inside them. They're trained inside Omniverse. And how about this? Let's show everybody the simulator that you guys learned how to be robots in. You guys want to look at that? Okay, let's look at that. Run it, please. Invisible bodies, we call them, she discovered dark matter, that occupies space even though we don't see it. And so Vera Rubin is the person that we named our next computer after. Isn't that a good idea? I know. Okay, Vera Rubin is designed to address this fundamental challenge that we have. The amount of computation necessary for AI is skyrocketing. The demand for NVIDIA GPUs is skyrocketing. It's skyrocketing because models are increasing by a factor of 10, an order of a magnitude every single year. And not to mention, as I mentioned, O1's introduction was an inflection point for AI. Instead of a one-shot answer, inference is now a thinking process. And in order to teach the AI how to think, reinforcement learning and very significant computation was introduced into post-training. It's no longer supervised fine-tuning, or otherwise known as imitation learning or supervision training. You now have reinforcement learning, essentially the computer trying different iterations itself, learning how to perform a task. The amount of computation for pre-training, for post-training, for test time scaling has exploded as a result of that. And now every single inference that we do, instead of just one shot, the number of tokens, you could just see the AIs think, which we appreciate. The longer it thinks, oftentimes it produces a better answer. And so test time scaling causes the number of tokens to be generated increase by 5x every single year. Not to mention, meanwhile, the race is on for AI. Everybody's trying to get to the next level. Everybody's trying to get to the next frontier. And every time they get to the next frontier, the last generation AI tokens, the cost starts to decline, about a factor of 10x every year. The 10x decline every year is actually telling you something different. It's saying that the race is so intense. Everybody's trying to get to the next level, and somebody is getting to the next level. And so therefore, all of it is a computing problem. The faster you compute, the sooner you can get to the next level of the next frontier. All of these things are simultaneously happening at the same time. And so we decided that we have to advance the state of the art of computation every single year, not 1 year left behind. And now we've been shipping GB200s a year and a half ago. Right now we're in full-scale manufacturing of GB300. And if Vera Rubin is going to be in time for this year, it must be in production by now. And so today I can tell you that Vera Rubin is in full production. 2 Vera Rubin, or 72 Rubins. Each one of the Rubins is 2 actual GPU dies connected together. I'm going to show it to you. But there are several things that, well, I'll tell you later. I can't tell you everything right away. Well, we designed 6 different chips. First of all, we have a rule inside our company, and it's a good rule. No new generation should have more than 1 or 2 chips change. But the problem is this. As you could see, we were describing the total number of transistors in each one of the chips that were being described, and we know that Moore's law has largely slowed. And so the number of transistors we can get year after year after year can't possibly keep up with the 10 times larger models. It can't possibly keep up with 5 times per year more tokens generated. It can't possibly keep up with the fact that cost decline of the tokens are going to be so aggressive. Of the world's most advanced CPUs. Its data rate is insane. It was designed to process supercomputers. And Vera was an incredible GPU. Grace was an incredible GPU. Now Vera increases the single-threaded performance, increases the capacity of the memory, increases everything just dramatically. It's a giant chip. This is the Vera CPU. This is one CPU. And this is connected to the Rubin GPU. Look at that thing. It's a giant chip. Now, the thing that's really special, and I'll go through these. It's going to take 3 hands, I think, 4 hands to do this. Okay, so this is the Vera CPU. It's got 88 CPU cores, and the CPU cores are designed to be multi-threaded. But the multi-threaded nature of Vera was designed so that each one of the 176 threads could get its full performance. So it's essentially as if there's 176 cores, but only 88 physical cores. So these cores were designed in using a technology called spatial multi-threading. But the I/O performance is incredible. So this is how we're gonna get everybody to the next frontier, to push AI to the next level. And of course, to build these data centers energy efficiently and cost efficiently. So this is it. This is NVIDIA today. You know, we mentioned that we build chips, but as you know, NVIDIA builds entire systems now. And AI is a full stack. We're reinventing AI across everything from chips to infrastructure to models to applications. And our job is to create the entire stack so that all of you could create incredible applications for the rest of the world. Thank you all for coming. Have a great CES. Now, before I let you guys go, there were a whole bunch of slides we had to leave on the cutting floor, and so we have some outtakes here. I think it'll be fun for you. Have a great CES, guys.
And cut.
NVIDIA Live at CES Take 4 Marker.
Boom mic. Action.
Sorry, guys.
Platform shift, huh? That should do it.
And let's roll camera.
A shade of green. A bright, happy green.
World's most powerful AI supercomputer you can plug into the wall, next to my toaster.
Hey guys, I'm stuck again. I'm so sorry.
This slide is never gonna work. Let's just cut it.
Hello? Can you hear me? So like I was saying, the router, because not every problem needs the biggest, smartest model, just the right one.
No, no! Don't lose any of them!
This new 6-chip Rubin platform makes one amazing AI supercomputer.
There you go, little guy. Oh, no, not the scaling laws.
There is a squirrel on the car. Be ready to make the squirrel go away. Ask the squirrel gently to move away.
Did you know the best models today are all mixture of experts?
Hey!